Okay, I'm calling this Lesson 5.3 Part 2. We just did not have time in our last class period to cover all the material, so there's one more type of problem that I really need to cover with you, and it's what you're going to be doing on page or problems 30 to 38 even, and I'll recap the homework for you after I finish two examples. So your instructions are given here for 30 to 38 even, and what we're trying to do, and this is an important concept that you're going to use again when you go to pre-calculus or algebra 3 later on. How do we determine whether or not a pair of functions are inverse functions? Or if you look at my statement here that I put a little asterisk by, how do we know when two functions are inverses of each other? Well, this statement tells you how we can find that out. Two functions are inverses of each other, and this little symbol here means if and only if f of g of x is equal to x. So in other words, when I put the g function as an input into the f function, the result should be just the variable x. And that should also happen when I turn it around and I do the composite g of f of x. That should also result in the variable x. If that is true, in both cases I get x when I do the composite f of g and also when I do g of f, then we know that the two functions are inverses of each other. And this is just another way of writing it using that composite symbol that your book uses. So that's what these problems are all about, finding out whether or not two given functions are inverses of each other. So let me give you an example. Here are my two functions, f and g, and it doesn't really matter how you start. Let's identify f of g of x. Now remember, you always use the function that's closest to the number. Now I know this isn't a number, but it stands for a number, a particular input. So we use the function closest to the number first. So the way this reads is I'm going to use the g function as an input into the f function. That whole g function, which is given as x minus 6 over 4, is going to replace x in the f function. And let's see what we get when we do that. Alright, so 4 is already part of the f function, and we're going to replace x with x minus 6 over 4. And then plus 6 is part of the f function. You can, since you're multiplying here, you can cancel this 4 in the numerator with this 4 in the denominator, leaving you with x minus 6, and then bring down plus 6. When you simplify, notice how you get regular x as the solution or the result of this composite f of g of x. Well, now to prove that they truly are inverses of each other, I now need to turn this around and do the other composite g of f of x. And if I get x for this result, I'll know that these are inverses of each other. So this time the f function is going to be used as an input into the g function. Let me erase this. Okay, so f, which is 4x plus 6, will replace x in this g function. So I'm going to do 4x plus 6 minus 6. That's the numerator, and the denominator is 4. 6 minus 6, of course, is 0. And I'm left with, sure enough, I'm left with f. So when I did both composites, f of g and g of f, in both cases I was left with the variable x. And so my answer for letter A is yes, these are inverses. These are inverse functions, or they are inverses of each other. Alright, so let's take a look at another one. Again, given two functions, let's determine whether or not these are inverses of one another. So again, just pick a composite. I'll just say f of g of x. So now the g function is going to be an input. This whole g function is going to replace x in the f function. Alright, so that looks like this. 2 times the square root of, now I'm going to replace x with 1/4 x squared minus 5. I'll put parentheses around it because I've replaced that variable. And then minus 5 was already part of that f function. Okay, I'll simplify as much as I can, but you're probably going to see pretty quickly that I'm not going to get x out of this. I mean, even if this did simplify, I'm going to be multiplying by 2. So the bottom line is that's as far as I can go. That does not equal x. So really there's no point in doing the other composite, because to be truly inverses of each other, I'm supposed to get x in both cases, f of g of x and also g of f of x. So my answer for letter B is going to be no. These are not inverses of each other. Okay, so again, make sure that you test both. If you end up with x when you do the first composite, you need to make sure that you go ahead and do the other, because it may turn out that the first composite equals or becomes x after you simplify, but when you turn it around and do it the other way, it does not. And in that case, those would not be inverse functions. Okay, so let me just get to the assignment. This is again part B. You've already done part of this assignment. So the part that remains for lesson 5.3 are these 5 problems, 30 to 38 even, doing exactly what I did on this video. And if you have any questions, feel free to contact me.